All right, here we are on section 4.4, more right triangle trigonometry. A lot of good review stuff, still drawing right triangles, still using our SOHCAHTOA. I would say the only big difference is the directions change a little bit, so we're going to have to talk about that. And the triangles are going to be moving around the 4 different quadrants more, so we need to talk about how to figure out which quadrant to draw it in. So just a few things to go over, definitions. We've actually been using reference this entire time. We haven't necessarily fancy phrase or word reference. So let theta be an angle in standard position. Its reference angle is the acute angle theta prime, is how you say that, formed by the terminal side and the horizontal axis. We've already been using that. So the angle between the x-axis and the triangle, of course, that's its reference angle, which evolved in 30, 45, or 60. To find the value of the function, of course, we are going to determine the function value for theta prime. Of course, we're going to watch our positives and negatives depending on the location of where the angle lies on the 4 quadrants. We have already been doing all of this. Okay, so don't let that weird you out. Okay, determine the exact value of the 6 functions of theta. Now, this time, different directions. They give you a point. So I'm like, okay, well, let's think about if we plot the point, 3, -1. Of course, from 0, 0, we go right 3 and down 1. So all I'm going to do is make my standard right triangle out of this. I'm, of course, going to connect to the point, and we always make the right triangle with our x-axis. Now, I don't know if the angle's 30, 60, 45, or something else. Doesn't matter, because for the 6 functions, we need all the sides. Well, this side's clearly 3, we went down 1. We can find the missing side here, the hypotenuse, with Pythagorean theorem. So I'm just going to calculate it out. 3 squared 9, -1 squared 1. We're going to add that up. And then we'll square root each side so we get the square root of 10. And I'm just going to label, because I don't know the angle theta. I'm just going to call it theta for right now. Now, all I have to do is, of course, crank out the 6 fractions. Sine opposite over hypotenuse. Now, yes, I have to rationalize it, and I will, but let's go ahead and list cosecant. I'm just going to use the reciprocal. And of course, let's just simplify that a little bit. And of course, you can go right to the answer. I'm going to back up, of course, and do my rationalizing, which I know some of you can just do this in your head, totally fine. I'm just going to write it out, of course, for your notes. All right, let's do cosine adjacent over hypotenuse, so adjacent 3, hypotenuse square root of 10. Let's go ahead and list secant, the reciprocal, which comes out super nice. And then I'm going to, of course, go back to cosine and rationalize. We need a root. You can never have that square root in the denominator. All right, last step for this one, tan. Tan opposite over adjacent. I like it, nothing to simplify, no rationalizing. Let's go to cotan, of course, the reciprocal of -1/3, -3 over 1, and clearly we don't need the over 1. So don't let the fact they give you the ordered pair scare you. That's really 2 sides of the triangle. You're going to have to find the third with Pythagorean theorem. Now, same type of problem. The point is on the terminal side of the angle in standard position. Determine the exact value of the 6 functions. And they give you the point 8, 15. So let's just, I'm not going to mark out 15. We can just estimate it. We know if we plot 8, 15, of course, it's going to be in quadrant 1. So I just drew kind of a large quadrant 1. We would go right 8, up 15. Good enough, okay? So, of course, I'm going to connect from my origin, and we always make our triangle with the x-axis. So to get to this point, I went right 8, up 15. So of course you need to find the hypotenuse, or maybe you know this one. This is a Pythagorean triple, 8, 15, 17. And I'm going to label this theta. Again, I don't care, 30, 60, something else. We're after all of the sides. All right, sine, of course, opposite over hypotenuse. No radicals, no simplifying. This will be a nice and easy one. I'm just going to do the reciprocal, 17 over 15. Let's do cosine adjacent over hypotenuse. And then, of course, let's list secant, the reciprocal, 17 over 8. All right, tangent, opposite over adjacent. Opposite 15, adjacent 8. And let's do the reciprocal. So again, the ordered pairs are really just going to turn out to be 2 sides of your triangle. Maybe you'll get lucky and get a Pythagorean triple. Otherwise, you can use your Pythagorean theorem to find it. Now, little trickier, how to figure out where to draw the triangles. Because sometimes it's not going to be quite as obvious, like the point 8, 15. We can all do that. So here's a little saying all students take calculus to try to help you figure out where to draw it. So I'm just going to draw our coordinate plane here. I'm going to label, of course, our quadrants. Okay, so the first letter in each word of the phrase all students take calculus is what's important. So I'm going to start quadrant 1 versus word A, all. That means all trig functions are positive in quadrant 1. I'm not going to list out all 6. Really, positive in 1. Okay, next word, S, students. So that's going to relate to our quadrant 2. So that means, of course, sine is positive in 2. And along with sine would be cosecant. So this little saying is telling you where the functions are positive. We'll talk about negative. We'll get to it. Okay, third word, T, take. So tangent is positive quadrant 3. And of course, obviously, cotan would be 2. All right, and then our last one, 4, C, calculus. So cosine is positive, and of course secant would also be positive. So this is going to give you a little shortcut, of course, of where the functions are positive. So let's talk about negatives, though. If we know, let's talk about cosine. Let's say you know cosine is positive in 1 and 4. That means cosine would be negative in 2 and 3. The opposite quadrants. So how you can figure out the negatives. So let me just erase these little green stars. Now, if we know, let's say we're talking about sine. We want to know where sine is negative. Well, sine is positive in 1 and 2. So therefore, sine would be negative in 3 and 4. The opposite quadrants. So that's what we're going to use to help us figure out where to draw some of these triangles coming up. So determine the quadrant theta which it lies. So I'm just going to draw the 4 quadrants here in the middle and use it for both of them. And I'm just going to show you my little shortcut how I draw this. I don't get crazy and write out everything I have here in this long description. Here's my little shortcut when I'm working on the problems. All students take calculus. I just put that down. So I know everything's positive in 1, sine's positive in 2, tan in 3, cos in 4. So I'm always going to try to work in sine, cosine, or tangent, the 3 main functions. So right away on A, I see secant. Well, whatever's true for secant's true for cosine. So cosine's greater than 0. Greater than 0, of course, means positive. So I'm going to look over here. Cosine is positive in 1 and 4. Everything's positive in 1 and 4. We got to narrow it down, though, here a little bit. Now, cotan. Of course, whatever's true for cotan is also true for tangent. So tangent's less than 0 also, or tangent's negative. So now I'm going to eliminate one of these green circled quadrants according to the fact that tangent has to be. That means I can't be in 1 because tangent's positive. So the only quadrant we could be in is 4. So sometimes it's a little process of elimination. Let's look at B. I'm just going to erase all my markings over here so we can redo it. Okay, tangent greater than 0. So greater than 0, of course, positive. So I'm looking where tangent's positive. Everything's positive in 1, tangent's positive in 3. Now I'm going to figure out which one is it, 1 or 3. Well, cosecant, whatever's true for cosecant is also true for sine. So sine less than 0, sine negative. So that means I can't be in 1. Everything's positive in 1. So I'm going to eliminate that. We would be in quadrant 3. So a little process of elimination. And I don't expect you to draw the all students take calculus every single time. You might just want to have it next to you as you're working on some of the problems. Find the value of the 6 trigonometric functions of theta using the given function value and the constraint. Well, I like this. Nothing to figure out. They're flat out telling you have to be in quadrant 3. So I'm just going to kind of draw an enlarged quadrant 3 here instead of the 4 equal quadrants. Make my right triangle. Now they tell us cosine's -4/5, so cosine's adjacent and hypotenuse. So I know adjacent -4, hypotenuse 5. We need the missing side. You could use Pythagorean theorem, or of course this is a triple, 3, 4, 5. And because of the location, 3 is on the bottom of the y-axis, so that needs a negative on it. Once you have all the sides, now we can just crank out the fractions. So sine, of course, opposite over hypotenuse. Then we're going to list cosecant. I'm going to just do the reciprocal. They already gave us cosine in the given information, so I'm just going to go ahead and list secant. You can write cosine again, but why? Let's just do the reciprocal, and then we'll do our tan and cotan. So tan, opposite over adjacent, opposite angle theta is -3, adjacent -4. Let's just make those two negatives a positive, and then cotan, of course, would be the reciprocal. So sometimes it will still be nice, and they will flat out tell you where to draw it. I like that. Not so lucky on this one. Okay, so again, I always think it's easiest to work in the main 3 sine, cos, tan, trig functions. So if cosecant is 4, you know what sine is. Sine, of course, is the reciprocal of cosecant. So the reciprocal of 4 over 1, 1 over 4. Cotan's less than 0. Also, tangent would be less than 0. So what's important to me? We have positive sine, positive 1/4, and a negative tan. That's going to help me figure out where to draw it. Now, because right now, I'm not 100% sure which quadrant, I'm just going to draw them all even. Now, I just do a little all students take calculus, just so it's in front of me to help me kind of eliminate or figure out, narrow it down which quadrant to be in. Let's start with sine is positive. Well, everything's positive in 1, and sine's positive in 2. So it's going to be either in quadrant 1 or 2 where we draw the triangle. We're going to use the fact that tangent is negative to eliminate quadrant 1, because everything's positive in 1. So I have to draw it in 2. Now, sine, opposite, hypotenuse. We clearly need to find our missing side, which of course we would use our Pythagorean theorem. I'm just going to call it x for right now. 1 squared plus x squared. 4 squared, 16. 1 squared is 1. Let's deduct 1 from each side, 16 minus 1, and then square root it. Now, because it's on the left side of the x-axis, I'm going to put a negative. Okay, we've got all the sides. Now we can, of course, clearly write out the fractions. We already have sine and cosecant here at the given, so I'm not going to rewrite those out. But let's do cosine now. Cosine adjacent over hypotenuse. And then I'm going to do secant, the reciprocal, which means we're going to have to do rationalizing. And I know a lot of you can just do the rationalizing in your head. Let's just do it. -4 square roots of 15 over 15. We've done it so much. Okay, tangent. Now remember, our given information, tangent should be negative, so I better get a negative fraction here. Tangent, opposite over adjacent. Yes, I'm happy we've got the negative, not happy I got to rationalize. Let's list cotangent quick. I'm going to do the reciprocal. When we flip it, negative square root of 15 over 1. Clearly we don't need the over 1. And then I'm just going to rationalize this. I'm going to put the negative out front. We usually don't leave a negative in the denominator of a fraction. Got it. So the tricky part is figuring out the quadrant to draw it in. We all know sine, cosine, tangent. We can all do the fractions. And the tricky part's going to be now figuring out exactly which quadrant to draw it in. All right, let's take a look at C. So tangent's undefined. I'm like, undefined, of course, means we have 0 under the line. Now 0. I'm like, I can't have a side of a triangle, 0. So right away I'm thinking it's not going to be a triangle. Doesn't mean I can't do it. I'm not going to give up. I think it's going to be one of our quadrantal angles, one of the points. So I'm just going to put the ordered pairs on, and then we'll look at that constraint. So 1, 0, because remember we're on the unit circle, radius of 1. Nobody needs to see me draw a circle. We all know my artistic skills, or lack thereof. Okay, I'm going to label each ordered pair, alphabetical order, cosine, sine. I'm not going to do them all, we got it. Okay, constraint. We are between our angle, theta, is between pi, so we're in radians, and 1 full circle, 2 pi. We're starting at 0. So remember, as we label around here, 0, this would be pi over 2, pi, 3 pi over 2, and then back to your full circle, 2 pi. So our constraint, of course, we have to be in between pi and then the full circle 2 pi. So I know I'm going to be down here in quadrants 3 and 4. So I'm looking at the -1, 0, the 0, -1, the 1, 0, etc. Clearly it's not all 3 of those points. We have to figure it out. Tangent, of course, undefined. 0 under the line. Now, tangent, we're going to have to use an identity here because on our points we just have cosine, sine. Tangent, of course, sine over cosine. So for that to be undefined, I need cosine to be 0. So it's going to have to be this point. Because on the left point, cosine's -1, and on the right, cos is 1, so not it. So I'm working off the bottom point. So man, I got a whole lot of information here. I know sine's -1. I know cosine's 0. We already have tangent undefined. I'm not going to rewrite it. We can get cosecant. I'm going to do the reciprocal of -1, which is -1. The reciprocal is 0. So 0, of course, is really on the top. It would move to the bottom. 0 under the line, undefined. We already have tangent. Let's list cotan. So cotan, of course, is going to be cosine over sine. 0 over anything, 0. So again, the hard part is figuring out which you are using. Anytime you see undefined given to you or 0, you can't make a triangle. It's going to be one of the special quadrantal angles. So just start labeling. All right, let's practice a couple more of those. Evaluate the trig function of the quadrant angle. Well, pi over 2, of course, we all know is 90 degrees. So I'm going to mark 90 degrees on the graph here. So we don't have to get too crazy and label the whole thing. Of course, we start at 0. Here's our 90. So our point. Ordered pair, x would be 0, up 1 because we're on the unit circle. Clearly, alphabetical, cosine. We need tangent. So I'm going to use the identity. Tangent's the same or equivalent to sine divided by cosine. So sine over cosine, 0 under the line. Got it. Undefined. All right, secant of 0. 0, of course, is going to be our starting point. So 0 degrees right here. I'm going to label the ordered pair. We would go right 1. Y would be 0. So again, I have cosine, sine. Well, we need secant. So we have to know our identity. Secant, of course, is the same as 1 over cosine. Cosine on our point is 1. 1 over 1, 1. Got it. So not too shabby. I almost kind of like the points better. I think they're a little quicker than having to draw out all the triangles and maybe use Pythagorean theorem. Now, we have done reference angles. We just haven't maybe called them the fancy little name. You're going to know how to do this. Find the reference angle theta prime. And so first, let's just, like normal, start drawing out or marking out 125 degrees. So vertex on the origin, initial side. So 225. I'm just going to label all of these. 225, of course, is going to be 45 beyond 180. So from here all the way around is my 225. Now, it wants us to figure out, of course, theta prime, the reference angle, meaning how much is in between the x-axis and where we ended up. Well, between 180 and 225, 45 degrees. So in the past, we've had that. We've drawn the triangles. We've done all of that. We just haven't used the fancy name reference angle. All right, in radians. I'm going to keep it in radians. I don't want to have to convert it into degrees just to convert it back into radians. That just seems like a whole lot of extra work. So I'm going to label in radians. So I'm at 0. Now negative. So I'm going to rotate clockwise or down, and we're scaling by negative a half pi, 90 degrees. Minus another half, minus another half, and minus one more half puts us at a full revolution. All right, vertex. Got it. So we're rotating clockwise or, of course, down. So negative, if it helps you, think of this as negative 1 2/3 pi. So I'm going to go negative a half, negative 1. Negative 2/3 is going to be a little past negative 1 1/2. So from here around, negative a half, negative 1, negative 1 1/2, and that looks good enough to be about negative 1 2/3. So the question is, of course, what is our theta prime, our reference angle? Well, that's going to be however many radians in this case is in between where we left off and the x-axis. Now don't let the negative, of course, get in your way here. That's just the directions. We left off at 1 2/3 pi is how much we covered. To get to one full circle, 2 pi. 1 2/3, to get me to a full circle 2, I need another third. And of course, you can put a negative on it. That's just the direction. I care about the third, that you know it's a third more to get you to the x-axis. That's what we need. All right, one more. And radians, no degree symbol. It's not a typo. I haven't lost it yet. Remember, pi is simply a number, approximately 3.14. Now again, negative, so we're rotating clockwise or down. So I'm going to start with our standard labels, negative pi over 2, negative 1.5 pi, and then the full circle. Now because negative 6.5, of course, doesn't have the pi on it, I'm going to go ahead and, of course, evaluate these with pi. I'm going to start on the left. Negative pi, of course, negative 3.14. Got it. Pi over 2, negative 1.57. Negative 2 times pi, 2 times 3.14, 6.28. And then negative 3 pi over 2 is about negative 4.71. I did use my calculator for that one. Don't tell anybody. Okay, so let's mark out negative 6.5. So we're rotating clockwise or down. So here we go. I'm going to start rotating. I'm at negative 1.5. I got to keep going. Negative 3.14. I got to keep going. Negative 4.7. So I'm going to do one full circle, puts it at negative 6.28, and I got to go a little more. So the question is, what is this reference angle? Theta prime. So in between our 6.5 and our 6.28. Well, I would just do that on the old calculator. Maybe you can mental math it. Let's just figure out what's the difference between our, of course, angle we drew and the full circle 6.28. And you come up with about 0.22. Got it. Just a little tricky. Okay, so be conscientious which quadrant you're drawing these in. Use your all students take calculus, and have a great day.